Well, hello to everybody. Um, I'm going to say this again. My name is Roberto Acevedo. I'm from Chile, South America. Now, in the second talk, I'm going to talk about trends in nanotechnology and application to the mining sector. The application to the mining sector are really important in Chile, since in Chile is based its economy mainly on metallic and non-metallic resources. And therefore, we need to do something important and relevant so as to improve the state of the art as far as the production, exploitation, and so on, a technique are concerned. In this talk, what I'm going to try is to talk for about 10 minutes, which I hope that I shall be able to go with that. It's not easy because the subject is very broad and there are so many implications. The very one is to start saying that all these subjects start with Richard Feynman, and this gentleman was a distinguished scientist, physicist, theoretical physicist, and back in 1959, he gave a talk in Caltech, and the talk was about the beginning of this nanotechnology, which is a very important branch, as you should know, in physics, and nowadays it has become too important. Uh, Essentially, nanotechnology is the ability or capability that people today may get to manipulate atoms, and from there to go stay into nano scale and to start working with nanoparticle, and therefore to look for application in so many areas. Um, well, talking about something which is really nice and lovely to hear are the application of nanotechnology to medicines, biology, and so on. And the work is really is great, and there are many research groups, very famous all over the world, working on this. Now, as myself, I started with this subject some time ago. That was a long time ago, about 4 decades, when I started doing relativistic quantum mechanics. And I found out that although the complexities of such a scheme, which is a relativistic quantum mechanics, there was so much to be done there, my dear friends, that uh, more people were really asked to do more work and to sum up efforts, energy, and money, because this is research, and the quality means two things simultaneously time and money. Without those two, you can do very little indeed. You can be a genius, but without the right equipment to validate your theoretical results and so on, it's not much you can do. In physics, the physics is based upon the experimental evidence. So you don't have it. What you have is some exercise of academic interest. This is what you have. Now, what I need to do now at the moment is to share the screen, which is something I'm going to do right now with you. There I am. So you're going to see my screen here. And what I actually need is here. Let me move this, and I go to this, and here a data. I have this in a folder called conference, which is well, if not is not there, it should be Congress or something like that. Well, uh, give me a second, please. What I would say is a conference. I think that is the name. There we are. Yeah. Yes. And conference. Oh, no, it's not Congress. I think it's a conference. Well, I'm sorry about this, but this is what happens. We can go quickly, and here we are. And let me second. This is let us rush Rahendra Nicola new carbon and nanomaterials, which is not the one I'm looking for. This is Morocco conference, and now here we are. I'm very sorry, but this is this is the situation. I'm going to put this upwards there, and from here we can manipulate what I actually have. Trends in nanotechnology and application to the minus sector. That is the subject. And it is there is someone who is very special here. Is Mrs. Isidora F. Garrido. She's a very clever student, and she's civil engineering at the moment, major mining, and she was my student, and she's really very good. We have Andres Soto. He's a former student of mine, and now the head of the civil engineering career at the university. Lemmy Muñoz, which is a friend of mine. He's a very good geologist. And myself, University of San Sebastian, and so on. This is something that I'm going to read. It's the only way I have, well, some minutes to go. Nanotechnology represents a revolutionary part of for a technological development for that concern the management of material at the nanometer scale, 1 billion times smaller than a meter. Nanotechnology factually means any technology on the nano scale that has a number of applications in the real world. That's what we are saying. Nanotechnology literally encompasses the fabrication and application of chemical, physical, and biological systems at a scale ranging from individual molecules or atoms to submicron dimensions. This is really very, very important indeed. And also the integration of the resulting nanomaterial into larger systems. It has the potential to change our perspective and expectation and provide us with the capability to resolve global issues. The discovery and use of carbon nanomaterial has allowed the introduction of many new areas of technology in nanomedicine, biosensors, and bioelectronics. This is what we are talking about at the very beginning. In recent years, nanotechnology has emerged as a multidisciplinary field in which gaining a fundamental understanding of the electrical, optical, magnetic, and mechanical properties for nanostructures promises to deliver the next generation of functional materials and wide-ranging applications. Nanostructure can also provide solutions to technological and environmental challenges in the area of catalysis, medicine, solar energy conversion, and water treatment. My dear friends, with that introduction, if you can think this very, very carefully, you will see that the potential of nanotechnology is too big. And therefore, what we should do with our students is really to seduce them to work hard and harder with us. And from the very beginning, from the scratch, we should be able to teach them a quantum mechanic technique of research, how to think properly in science, the, the general theory of system, the scientific methods, and so on. So there is a task which is getting more and more complex for teachers, lecturer, and professor, and masters. And as we can see, the number of application is huge. Now, there is something I have to tell you. All the details about this, the implication in the economy and so on, in this country and all over the world, my dear friends, are very well treated with the time and the effort and the energy in the chapter book, which I have already submitted, in the hope that this is going to be published as well. Next, I don't have much time, but I need to say something. Some preliminary remarks, an interlude. I'm going to say, not to read phrase by phrase and so on, but let me say something. Some preliminary words about the subject are with reference to some preliminary words focus on the epistemological current status of nanotechnology. We might argue a twofold thesis. On the one hand, nanotechnoscience is not just one more chapter in the history of science and technology, but it is a substantial and radical shift that opens new and unpredictable horizons. On the other side, nanoscience can and must be seen as a new science, namely a cross-disciplinary and border science. That is really, 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 really very important. Along this line, the very question regarding the philosophy and nanotech science deal with a science defined by border problems, which can shed new light into similar science, such as science of complex systems, for example. Whilst nanoscale research cannot be seen as a reductionist from a philosophical viewpoint, the core subject lies on the concept of a scale. This is something that we need to explain in more and more detail. And it has been done with a lot of care, a lot of patience, my dear friends, and with the effort of many people who has worked with us for some time to prepare all of this. On top of this, our lecture are focused on those subjects which has the potential and they are really, really relevant for international country and I assume that everybody all around the world. There are 2 points which are very important, and we need to focus on that: energy and water. Nanotechnology can play a very important role on that, and therefore, our emphasis should be focused on this kind of subject, and we need to learn more. We need to learn more and more. It is very true that the more we learn, the more ignorant we become, and this is quite true. And I'm very happy about that because nothing has been solved 100%. There is no way to do so. No one can claim that. This is the second point is some outstanding application. I'm going just to mention them. Nanotechnology and its application in energy generation. We are talking about that. The second one is some additional application of nanotechnology. For instance, where this word is not easy to pronounce. It is derived from renewable. So you have to say renewable energy store, battery, and supercapacitors. Those are other applications. Here we have renewable energy. And nanotechnology may also facilitate the generation of electricity directly from solar, wind, and geothermal sources. Well, this is very important. And if you read the presentation carefully, you will see that there are so many things which are common, and you can do something about this. That's I. This is double I here. Energy stores. Here, my dear friend, the work done so far is really fantastic, outstanding. Triple I battery. Here, the work is amazing. We have done a lot of work on this. And I cannot say that we have solved very capital problems. All I can say is that we are trying. That's all. I'm trying to be a very humble fellow all my life. And I'm very careful about what I'm saying. Then we have capacitors with the definition and the conclusion, which are very important. I had to go to make a quantum jump because, and I think my time is over. Nanotechnology has made enormous progress over the past few decades. In summary, nanotechnology requires the measurement, prediction, and fabrication of matter on the scale of atoms and molecules. It is hoped that atomic scale nanotechnology will have a revolutionary impact on the way we do, design, and produce things in the future. Nanotechnology is an atomic or molecular approach to building physically, chemically, and biologically stable structure, one atom or another molecule at a time. Today, scientists and researchers can control atoms or molecules individually and can manipulate them, as Richard Feynman said. They must well use them to achieve phenomenal degree of precision. Nanotechnology contribution to society may appear small at the moment, but we continue manpower and funding, it is hoped. It will provide results and innovation if nanotechnology continue to grow. At its current rate, it will touch the life of nearly everybody on the planet in the next few years. We're talking about the medium term. Here you have results of investigation and development in nanotechnology fields and entry into all areas of our lives, such as agriculture, aerospace, energy defense, material science, environmental science, and medicines. Nanotechnology, my dear friend, is developing quickly, with its application being investigated by an increasing number of scientists and clinical, government agency, venture capitalists, and politicians. Some active research areas include nano lithography, nanorobotics, nanodevices, nanopowders, nanocomputer, nanoporous material, and nanostructure catalysis, molecular nanotechnology, molecular manufacturing, nano layers, medicine, and nanobiology. Here I have listed the more relevant. This is not complete, the list of reference, but I cannot carry on because I could stay here for hours, but that's not the point. All I can say is that if anyone wants some more information, well, there are two ways. The first is to wait for the book, the international book, to be published, in the hope that these works are going to be accepted for that. Or secondly, just write to me, and I will more than happy to work with any one of you and to contribute in any possible way I can. We are far away from you physically, but in our heart you are very close to me. Thank you very much indeed, and I hope that you enjoy the presentation. Goodbye.